Okay, in this video I'm going to talk about proper coloring of graphs and the chromatic number of graphs. So, let's say that we have a graph and we define a color, and so we consider the colorings of the vertices of this graph. So we define that this coloring is proper. So a coloring of the vertices of a graph is said to be proper. If any two adjacent vertices get different colors. If any two adjacent vertices get different colors. So basically, like if we have an edge in a graph, then these two vertices that are adjacent, that are connected by an edge, they must be of different colors. So like the situation where they are of the same color is prohibited. So that's the main forbidden element in the colorings. So now this is the most popular or the most commonly considered colorings among like all the various colorings of graphs that are considered. It's kind of the most popular and the most commonly considered. So now we define the chromatic number. So the chromatic number he of G of graph G, so it is denoted by he of G, is the minimum number of colors required for a proper coloring of this graph. For proper coloring of G. So so basically, like it's obvious that we can't. So the only graph. Okay, so let's consider several examples for some classes of graphs. So the only case when he of G is equal to 1, it means that we can color the vertices of the graph properly in only one colors, like on only one color. And the only case where this can happen is when we don't have edges at all. So like we have a bunch of vertices but no edges in the graph. then we can color all these vertices in the same color, because if there is an edge anywhere, like at least one edge, then the vertices at the ends of this edge must be colored differently, and so therefore we must have at least two colors. So the equal to 1, it follows that the graph G has no edges. So another kind of the opposite case, when the graph is complete. So when we have a complete graph on n vertices, so it's denoted by Kn. It's a complete graph on n vertices. So complete, it means that between any two vertices there is an edge. So there are all possible edges that could be for these vertices. So in this case, yeah, this one. So this is K5. So on 5 vertices. Let's find what is the chromatic number of the complete graph. So it's obvious that it should be n, because first we can color the edges, the vertices of this graph in n colors simply by giving a separate color to each vertex. So like all vertices have different colors. Then of course any two vertices that are connected by an edge have different colors. But on the other hand, it cannot be less than n, because if we have less than n, then at least two vertices would get the same color, but these two vertices are always connected, because any two vertices are connected by an edge in the complete graph. So, or like another way to put it, since any two vertices are connected by an edge, then any pair of vertices, like all pairs of vertices, must have different colors. So basically it means that all vertices have pairwise different colors. So like it must be n different colors, one for each vertex. So these are kind of two opposite cases for a graph without edges and for a complete graph. And for all other graphs, it's somewhere in between. So this could be kind of a lower and upper bound. So it's always less or equal than n, and more or greater or equal than 1, where n is the number of vertices. N is the number of vertices of G. So now let's consider one more case, is when basically bipartite graphs. So bipartite graphs. So for this class of graphs, I made a separate video about bipartite graphs, and basically the definition of bipartite graphs is that we can split all the vertices of this graph into two sets, such that all the edges in the graph are between sets but not inside. So such edges are prohibited here and here. So such edges are prohibited, and all edges are only between the sets. So notice that this exactly means that the graph is too colorable. So bipartite graph, it's the same as too colorable. Yeah, and by the way, I forget to make another definition that the graph is are colorable. So let's say that, yeah, let's put it as a definition. A graph, it's kind of obvious, but it's useful to put it as a definition, is are colorable if there is a proper coloring, there exists a proper coloring of this graph in R colors. Yeah, so too colorable, it means that there is a proper coloring in two colors, and like it's obvious what this coloring is. So we simply, like, these two sets, bipartite graph is by definition, like if its vertices can be split into two, or can be partitioned into two sets. So we color the first set into color 1 and the second set into color 2, like all the vertices here and all the vertices here, and this is the coloring. So like partitioning into two sets and coloring, it's basically the same thing, just two different ways to view the same concept. So yeah, so for bipartite graphs, so it means that the chromatic number is less or equal than 2 for bipartite graphs. So bipartite graphs are exactly the graphs for which the chromatic number is less or equal than 2. Yeah, so there are like a lot of properties of the proper colorings and of the chromatic numbers. Like obviously I can't cover all of this in this video. Like some of them, like I actually already covered. Like I made several videos where I already talked about the chromatic number and the proper colorings. And this is kind of the proper colorings is the most studied. Like I would say it's probably the most studied topic in graph theory. So yeah, so this is a kind of the most important definition in graph theory. At least one of the most important. Yeah, so that's it for this video.